All right, so I'm going to talk about the power SQL. So recently, and I think kind of over time with Osquery, there's been, like, for newcomers, you're always like, SQL, like, I know it's a way to query things, but it's a unique feature of Osquery and different from everything else that I used in the past before that. So if we rewind back a few years now, I think I first used Osquery in 2014. It was long before Windows, not long before packs, but there were no packs. You had one config file, and I think the format maybe changed, but at the time we had a logging infrastructure. We were collecting information about our machines. But this new thing came out called Osquery, and it was going to log more information and changes about the machine. So we pushed it out, and we had some queries running, and those ended up in our logging infrastructure. But really, all I could say was, I have no idea what I'm doing. We had some scheduled queries, and they logged changes, and we could go into our logging infrastructure and maybe see what some of them were, and like maybe use them for some incident response. But at the end of the day, really, we just had this program. We were a long way from knowing like what this tool was really for. I don't really know if 4 years ago anybody, even those who were the Osquery developers at the time, truly knew what it was or was going to become. But it's become something real today. But I remember thinking back then, I was trying to write some queries, and I kept saying, like, why SQL? So SQL to me at the time was really part of this classic LAMP stack, right? You had Linux, Apache, MySQL, and PHP. So you could run, your WordPress site or Drupal or Joomla or whatever, and you would go make some SQL database, and you had this awesome interface to it called PHPMyAdmin, and like that was SQL to me. It was a place where you stored things, and then you could query them back later. But you honestly probably didn't do any complex SQL operations. But this is what SQL was to me at the time. Today, if you ask me about SQL, it's a very different thing. There's little SQLite databases on your Mac for little things, but to me, today, if you mention SQL, it's the interface to Osquery. That's the primary thing it is to me. So, if I think back to 2014, we did have ways to query information about our machines. At the time, and still today, Factor which is part of the suite that you use for Puppet, was a way to query things about the machines. So let's say we wanted to find out if Xcode was installed on a Mac. We would write this Ruby script. It would, add this fact, and it's pretty simple. It would just, use Ruby to see if a file existed and return true or false. Or, maybe you had some other management tool for your machines. So you needed to write an extension attribute. So you could write that in Bash, and it would return some XML. But, there's a lot of lines in those scripts, and there's a lot of, you would copy and paste the same thing over and over and over again. So you'd have one for, Xcode installed, one for whatever, Android Studio or whatever other developer environment, so you could act upon that. But we could really just write one line of a SQL query and get back, roughly the same information. We could get back a lot more information, but this is much simpler. So how about something a little bit more complex? So on the Mac, you can define a separate software update URL. But unfortunately, the Mac management tools are pretty much all written in Ruby. But to query things properly to find out what the actual preference you're going to resolve is, there's no interface for that in Ruby. So we end up shelling out to Python to talk to PyObjective-C to query something back. And there's so much of this all over the place, whether it's in Puppet or Chef or any of that. And it's just to query one key in a preference. Like, this is too much. Or we could just write, one line of a SQL query that Osquery will give us, and we can get back the same information without running Ruby to shell out to Python to Objective-C. Like, it works, but running this, it takes time. If you have a lot of these things, it makes your configuration management or whatever your reporting tool take quite a while to run, because you're loading Ruby and then loading Python every single time. It takes time, it's complex. Why don't we just have one line to do it? So what I really want to talk about is a strategy for query use. So I'm going to assume that by now you figured out how to install Osquery, and you have the logs from it or the results from it going somewhere. It might just be locally on your disk. So you're just querying them in console or looking at the text files. Or maybe they're going to a tool like Splunk or Sumo Logic or Streamalert. Something that can process them, someplace you can search them. All of this can be fairly easily set up. So there's a few different types of queries that when you're starting to build packs, when you're starting to build your configuration, that you probably want to wrap your head around. The first that you're going to encounter is what I would call a basic query. And this is like the most common type of query, what you'll see in the stock packs that Osquery comes with, most likely. They're mostly going to be just select star from table name, and you're going to get results over time from them. Now you're going to get a lot of data from these, or at least, probably more data than you would want right now, but that data is pretty valuable. However, you're going to have to do something intelligent with them on your back end, whether that's your log aggregation tool or locally or whatever. If you want to, if you're looking for something specific. So there's going to be a lot of noise. Really depending on what table it is, but some tables, if you do select star from table name, can return hundreds of thousands of lines. Some might just return one. So some basic queries that you might see would be, select star from DNS resolvers and return some DNS servers, or select star from OS version. And these are going to change. They're going to give you added and removed results over time. And these are pretty basic. Like, these are ones that you're probably going to want to run as, select star and get everything back. It's not going to return very much, and it's valuable information. But then if you just move on to some other tables, which I would call like medium-sized tables, you might run like select star from users. Well, this really starts to add up. On your Mac, there's your user account that you actually use, but there's a whole bunch of system accounts that are used for all kinds of things, to run all kinds of services. Whether it's to mount disks or, run a caching server or all kinds of different things. And you're going to get a lot of data from this. And you might say, these queries are giving me too much data. So you're going to move on to what I would call a limited query. And what a limited query is to me is an adapted version of a basic query where you said, I was getting too much data back. I want to look for something more specific. So in the SQL syntax, you're probably going to have a where and limit back what you want. So if you're looking for users, you might key off what the UID is, or you might look for a string and match on a substring. But you already kind of have some intelligence that you've defined of the data that you want, but you don't have quite everything. So you don't want to get all the data the table can give back to you, just some of it. So you're designing these to be low noise, but you're intentionally throwing some data away. So if we look back at that user's query, I was getting back so many things. If you look on a Mac, all the users that I created through GUI are going to have a UID that's greater than 500. So pretty much all the system users are going to have a UID that's below that, and I just want to find out who the actual users are on a machine. So I can say in my SQL syntax, select star from users where UID is greater than or equal to 500. And I get back, my user at the end. I install Mac ports on my computer, so that creates a user. And then you get this nobody user, which has an extremely high UID. I think that's like the maximum integer that can be stored there or something like that. But you're going to limit back what you get. And this can be pretty good because you're getting the data that you want, and not it's easy to zoom in on what you need. However, for some much larger tables, this can really benefit you. So if you run a query like this, select star from ASL. So this is running right now. But if you run a query and your computer starts doing this, it's probably too much. I think, because I'm running this in terminal and it takes a while for the standard out to write out, it is a little slow, but I think it takes about 5 minutes for this to write everything out, and obviously this is unusable. If you're running this as part of a pack and it's programmatically sending data back, that might be a little different, but you still probably want to limit what you are querying. I mean, there's definitely some data you want that pops up there at some point, right? But the reality is that if you use the count function, there's 205,000 lines that are going to print out from that query, right? Or that are going to be returned. So that's a lot to parse. You could send 205,000 lines to your log aggregation service, but maybe you don't want to do that. Now, we can obviously limit the ASL query based on a lot of different things, based on sender, facility, or anything we want. But I do want to talk about the problem with limited queries. And the problem with limited queries is when you're throwing data away, when you're ignoring it, you're going to miss things. And what I like to say here is there's probably never too much data unless you're dealing with an ASL size table. So if we look back at that users table, the reality is that this table honestly isn't very big. It's too big to be readable on a slide, but it's not too big for a computer to handle, especially in Osquery when you're scheduling queries, and it's only going to report the changes over time. Now, if you push out a query like this, where you're limiting the UID, as an attacker, I can read your pack and see that, hey, if I want to add a user to a machine, I just need to make the UID under 500, and it's never going to be seen. So maybe we shouldn't throw away that data. Now, another example of a limited query is, so I heard about this new malware that came out for Windows, and I need to detect it. And so I want to write a query that goes into my my Windows attacks pack. So I want to detect BonziBuddy, so I'm going to go over to a pack entry that I already wrote. So I copy Kazaa. I want to find all the Windows programs that match Kazaa, but not K++, because we know that one is not malware. So I'm going to copy that, and I'm going to change it over, and we're just going to find ones where the name is BonziBuddy. And then if a system has that on it, it would report back to me. However, do we really need to do this? Could we just write a general query that just queries Windows programs and report those always? And we could. So this is going to report more data, and it's going to report every Windows program on your machine. But you aren't going to have to copy and paste the same query over and over again. So you're not going to repeat yourself. But of course, don't repeat yourself is a great method to being a good lazy sysadmin, which is probably where a lot of us came from. But for a security tool, history matters a lot. So if we just ran a query like this, we pushed it out, we're not going to know if a machine had this malware on it, last week and it got removed. It's going to be gone already. And we also need to wait until this query has been pushed out by our configuration management tool or by our TLS server. It has to be run, and then we can find the data out. If we're just continuously running a query that gets our Windows programs, we're going to be sending that data up to whatever aggregation tool we have, and we can search back in the past. So history matters a lot. So those are kind of my mentalities on basic queries and limited queries. Say only use limited queries when it's actually giving you too much data back. Data that would actually never be valuable. If you're using the ASL table and you want to gather all the logs, maybe you would select star from ASL, but exclude everything that's from the Windows server, because the Windows server is 75% of the stuff in ASL, and it's just from pixels failing to draw. You probably don't care about that. And it's just going to be a complete waste. So moving on to the final type of query, I would call an advanced query. And these are the kinds of queries that you would probably never run in MySQL, at least if you are not an elite database admin. I never was. I just ran WordPress. So an advanced query can basically be described as putting a query in your query, because you need to bring data from multiple tables together. You can't just get the data from one. If you look through the packs, through the stock packs, or the examples that you'll commonly see with Osquery, you'll see a lot of queries where a table won't work or won't work properly without being fed some other data in. So the Safari extensions table really requires user ID to work properly, because Safari extensions get installed inside of user accounts. So if you just looked at the Safari extensions table and Osquery is running as root, it's only going to know to target that user. So, you'll commonly see things like this where Osquery is going to look at the users table, find all the users on the system, and then join that against the Safari extensions table to get everything back. So this is like the most basic advanced query. You're taking two things, putting them together, and getting data out of it that you couldn't just get from one table. So I wanted to write a query, and this is a common thing that needs to be achieved, in systems management, especially of laptops and endpoints, and find out who the current user is of the machine. So we can work through this. Now on the Mac, the file dev console is always owned by the current user of the machine. So if we look at that file using the files table, we can feed that file in and find out who the user is, who the owner is of that file, and we can find out what the UID is. Now the UID is nice, but it's not really friendly for me. I don't know who 501 is, and it's probably going to be 501 on every machine that I have. So we can take that 501 and run a query inside of another query to look at the users table, and I want to find out everything about the user ID of the owner of the file, and we can get this third result. Now all I really care about is the username, because I could have gotten the UID and the GID from the original query, but yeah, that's the power of doing that. So if we want to go, a bit more deep and limit things and join things, we might want to do something like this. So I have Santa on my machine, and Santa logs out to AppleSys log. And what I want to do is find out details on the files of every process that's been executed over time. So if we select messages from ASL or the sender's Santad, we're going to get back a big message that is pipe delimited, and then each of those sections are delimited by a equal sign. So we can split it twice and get what the path of the executable was, and then we can pipe that into the file table and get more out of it. Now, I limited this to 10 results because there's thousands of executables that have been, processed over time on my machine. But, when we start getting into this, we could make an even more advanced version of this where the Santa messages have what the UID and GID was at the time of execution, and maybe we could extract those and select, I want to find ones where it's changed since then. Maybe some permissions are changing around oddly on a system. And then we can, I didn't put that up there because that would just be like a crazy query like this, but these are all things that we could do in Python or Ruby or whatever our language of choice is, but it's just so simple inside of a SQL query, inside of Osquery. Now I had something I needed to investigate, and what I wanted to do was find out more information about the executables that were going to be run as part of launch agents. So if you're not familiar with macOS, launch agent is basically a service that will run as the user on the machine. And they're all defined in property list files, which are XML. But an interesting part about the launchd syntax, or schema, I guess, is that the program that will be run can be defined in multiple places. So if we look on the right, it's pretty simple. There's a key that's a program, and then it's just a string, a path to an executable. That's pretty simple. However, on the left side, we can see that Google Software Update doesn't have a program key. Instead, it has this program arguments key. And it's an array, and the first element is the program that will be executed, and then the rest of the elements are arguments to that original program. So I want to get, it's pretty easy to get the program from the one on the right, but I also want to get the program from the one on the left. And I'm going to do it in one query, and then get information about those files. So this is where queries start to get a little long. And I'm running multiple queries and using SQL syntax that I definitely had to Google when I was writing this, because again, I'm basically a WordPress admin. So what I wanted to do was find all the files, and I only wanted launch agents. I did not want launch daemons. Launch daemons are services that run as root. And I also wanted to ignore anything that was in the system folder. So the system folder is basically owned by Apple, and it's going to have a lot of things in it. And now with system integrity protection on the Mac, I'm not super worried about things popping up in there. I just want to find out about launch agents that have appeared on the system, whether they're in the user's launch agents folder, the system launch agents folder, not the computer's launch agents folder, not like in system. I guess that's kind of an odd peculiarity about the Mac, but here we can, the first part, the first part is pretty simple, where it selects from the file. We're querying the file table, but I need to feed a path into that. So paths can be in two different places, so I need to run two separate queries against the launchd table. The first one, we're looking at substrings of program arguments of the first one, and there's some weird case stuff in there because they can be of varying lengths, and the way you get the data back is a little odd. But we can use the union feature of SQL to merge multiple lists together and then feed them back in. And in this way, we can get all those programs and then feed them into the path, feed them into the file, and get more information about them. In my real query here, I do select star from file, but if it's too big to display on here. But I hope that a query like this, which starts to get long, it's by far not the longest query that I've written. I hope that can kind of inspire those who are approaching SQL in an Osquery way to, do more interesting things and adapt. But I really want you to know, you got to know how to use SQL if you want to write a query, but that's pretty easy to find in Google. But the key is to know when to use each type of query. And the way that I just look at that is like the old food pyramid. So basic queries, they're very broad, and we're gonna run them all the time, and they're gonna collect a lot of information. They're gonna provide us a lot. But you're gonna have to parse them and do things to them later. Limited queries provide you the core of what you are actually looking for at the time, but you should probably use them sparingly. They're not really super great because you're going to be missing information. And advanced queries are great too, but they can probably drive you nuts writing them. So, put them in the middle. So that's basically the approach to SQL that I've kind of taken over the last couple of years. And that's it.